converting rectangular coordinates to polar coordinates. So when we're converting rectangular coordinates to polar coordinates, that means that we're going to be starting with some xy ordered pair, and I want to convert that into an r theta ordered pair. Example, the following ordered pairs are given in rectangular coordinates. Convert to polar coordinates and graph to check your work. So in part A, I have the rectangular coordinates 0, -2. So if I were to just graph that in a regular xy axis, I would be down here, right? Left to right, 0 units, but then down 2 units. So there is my point, and I say, well, what is that in polar coordinates? So sometimes I can do this by inspection, meaning like if I can identify the terminal side on which this point is resting, so in this case, I can see that the terminal side is 3 pi over 2, right? So this angle here is 3 pi over 2. And then I look at the distance from the origin, and I know that has to be a length of 2 here. So here r is 2, and then my angle is 3 pi over 2. Then the polar coordinates here have to be r first, 2, and 3 pi over 2. And that's just from inspection. But this just kind of happened to work out nicely, so sometimes we can do that. But for ones that don't work out so nicely, then we gotta do it a different way. We gotta use some formulas. So let's check out what those formulas are. So we know that the points on a circle of radius r satisfy the equation x squared plus y squared equals r squared. And we know that the tangent of theta has to equal y over x. And again, we're assuming that the point x, y is on the terminal side of some angle theta in standard position. So this gives us some relationships between x and y and r and theta. So how can we use those here? Well, again, we're starting with x and y, and we're trying to go to polar coordinates. So if that's the case, I'm going to say, all right, let's say I'm trying to find r first. Well, r squared is going to be -√6 squared plus √2 squared. So r squared is 6 plus 2. R squared is 8, so r would have to be √8. Now, why am I picking positive √8 instead of negative √8? Well, because r is representing a distance, so it has to be positive. All right, what about tangent of theta equals y over x? Well, if I have tangent of theta is, let's do y over x, √2 over -√6. This is going to simplify to be -1 over √3. And I can think about where that is going to be. So I can use, so again, this is tangent of theta is -1 over √3. I can do tan inverse of this value and get out some angle. And I can think about what that angle is. This is going to be negative, so I'm going to be down in quadrant 4. Think about where tan inverse returns angles. It returns angles from quadrant 1 and quadrant 4. Okay, so how do I know which one it is? Well, I can always just try and go, well, wouldn't this be √3, let's try √3 over 2 divided by 1/2. That gives me √3 over 2 times 2 over 1. This is √3. That's not going to do it. I have 1 over √3, so try the other way. What if I have 1/2 divided by √3 over 2? That gives me 1/2 times 2 over √3. So this gives me 1 over √3. Okay, so again, for tangent, I have y over x, so I need this to be the y and this to be the x. Well, where is that going to occur? Well, y is 1/2 when I am down at -pi over 6. Again, I need this to be negative because I have a tangent of theta is -1 over √3. So when I'm in quadrant 4, where I'm expecting tan inverse to return, I would have a negative here, -1/2, which returns that negative value that I want. Okay, so tan inverse of -1 over √3 is going to give me -pi over 6. So I'm getting close to getting some of these values. Let's go ahead and plot the x and y that I was given originally to kind of check what quadrant am I going to be in, because tan inverse just returned an angle in quadrant 4. That could work, but I need to see where this point is. I see negative x comma y. That's in quadrant 2. So let's plot that and see where I am. So if I do root 6 just to see approximately, it's about 2.5. Okay, so negative 2.5 is about, I'm just going to draw in a straight line up and down about where that's going to be. And then root 2 is about 1.4. Let's just make sure. Root 2 is about 1.4. So that is, about here. Okay. So I'm expecting the point to be right about here. All right. And that is on, it looks about the 5 pi over 6. Okay. But again, this tan inverse is only giving me an angle down here in quadrant 4, right? It gave me this angle, negative pi over 6. Okay, so what I need to do is add pi to that. So what I found, so I'm going to erase this work of me trying to figure out what angle I was at. Okay. So what I'm going to do is take my negative pi over 6 and add pi to it. And I get 5 pi over 6. So let's see if that, that would be root 8, comma, 5 pi over 6 for my polar coordinates, which is what I was trying to find. Am I at 5 pi over 6 for my angle? I am. And what about root 8? So let's find out what root 8 is. 2.8. So am I at about 2.8? Let's see. Here's about 1, 2, 3. So yeah, that's about 2.8. And one thing that we can do is write this as 2 root 2 because we often want to simplify. So if you're feeling like a stickler, there we go. Okay, let's look at this last one. So part C, the point, negative 0.8, comma, negative 2.1. So this is a point in rectangular coordinates. These are my x and y. And I want to go ahead and find my r and theta. So I have r squared equals x squared plus y squared. So I have r squared equals negative 0.8 all squared. And make sure that these negative signs are within the squaring so they go away upon squaring. So negative 0.8 squared plus negative 2.1 squared. So I have r squared. I'm going to actually just solve for r. R is the square root of negative 0.8 squared plus negative 2.1 all squared. So if I go over to my calculator, I want the square root of, I'm just going to write it as 0.8 squared since that's going to give me the same thing, plus 2.1 squared. So I get about 2.25. So r is approximately 2.25. Okay, so if I'm building my point, I have my r value there. And if I go to graph this, I've negative 0.8 comma negative 2.1. So negative 0.8 is about here. Negative 2.1, I don't know, about there. So that's going to be, somewhere like right here. Okay, so let's see if that'll work. I'm in quadrant 3. If I do my tan inverse of my y over my x, I get out an angle. But this is going to be tan inverse of a positive value, which is going to give me something up here in quadrant 1, so I can see what that's going to be. First, I'm going to turn this into radians. Then I'm going to go to my function category, go to tan inverse. Oops, I need a new line first. Let's do that. So I'm going to do tan inverse, and I'm going to have, go back to my main menu. I'm just going to do 2.1 divided by 0.8 since those negatives are going to cross out. And so when I do that, I see that I get 1.21. So this is about 1.21. But this is about 1.57 radians for 90 degrees because it's half of pi. This is 0. So 1.21, is somewhere like up here. Okay. But quadrant 1 is not where I want to be because it needs to direct me to the point down in quadrant 3. So I need to add pi to that. So my theta is actually going to be, I guess I need approximate, 1.21 plus pi. So theta is approximately, so I'm just going to take this answer and add pi, and I get about 4.35. So there's my 4.35 radians, and then I have finished finding my polar coordinates, which are r and theta. So the main thing is starting with, whenever you're doing this, it's going to be starting with these conversion formulas. So x squared plus y squared equals r squared, and then tangent of theta equals y over x. So we know that r always has to be positive, and then using tan theta equals y over x, oftentimes we do need that inverse function, and then keeping in mind the inverse function can only give us angles that are in quadrants 1 and quadrants 4, and so if our point is living somewhere else, then we need to adjust by adding or subtracting pi.